So when you click the link for the part 2 of this lab, you should be taken to this web page. So all you're going to do here is you're going to just do a little practice of locating an earthquake with doing evaluations of seismograms, and then you're going to try to calculate a magnitude looking at the height of different waves, right? So it still walks you through some of the kind of descriptions of how we use seismic waves and what they are, which has been reviewed in the lecture. But here you'll have the opportunity to choose, and you can choose any of the 4 here that you would like. And so you choose one, and you're just going to walk through this activity here. So certainly some of it is just explanations. It's showing you the map for what you've chosen, shows what a kind of typical seismogram might look like, and then it's going to show you some seismograms so that you can calculate a location. What you're going to do on these is use this time scale here on the bottom. So this is in seconds, and this is to measure the height of different waves. So for the first part, because we're trying to find an epicenter, we just need the lag time, the distance or the change in time from the arrival of the P wave and the S wave. So this is 0. You're just going to have to figure out what each box represents and figure out how many seconds have transpired. And you need at least 3 to do that, and then you're going to hit this convert button. Now, of course, I can't skip through this without putting in the answers. So what you're going to end up seeing next is, oh, don't want to do that. Yeah, let's do this. So when you go next, what you're going to be given is this chart. So remember, in lecture we talked about you need this chart here that relates the lag time, that's what this is, with distance. So it carries over your measured lag times from the previous page, and you need to use this chart. So find your time that you got here, and then put in the appropriate kilometers, and then it'll use that information to triangulate, and you'll get some type of location here. It'll tell you how close you are, and if you can do that accurately, it'll let you move on. And then what you're going to do is, now that you know where it is, you need to know the size. So you're going to come to a page eventually that's going to ask you to measure the height. And so you want to measure the S wave height. So you're going to use this scale now to measure that. You'll enter those in there. And from that, it'll convert that to a magnitude. It'll ask you to read off the magnitude scale in the activity and enter that. And then it'll compare it to what the actual magnitude of that earthquake was. And if you do a good job, you'll end up coming to this page here. And so what I want you to do is enter your name. Enter MCC, or Mesa Community College, and I want you to put the date you did it right here. So October 2nd, or whatever date you're doing it, 2020, in this thing here. And then hit Get. I don't want you to email it to me. I want you to hit Get Certificate, and then you're going to get something like this. I need you to take a screenshot that includes the certificate and this data box. They're set up right like this on the final page when you hit Get Certificate. And so then you can just capture this part of the screen. That is what you need to upload to earn the points for the lab. Okay, so walk your way through. It should be fairly simple. You're just kind of, it just gives you an idea of how we would measure things on seismograms, right? And calculate distance, which would give us the epicenter, and then give us the magnitude of the earthquake. Okay, so make sure this is what I need, and I need the certificate, and I need the table, and I need your name, MCC, and the date. Otherwise, even though I know it gives it here, I want you to put it there anyway, okay? So if you could do that for me, that would be awesome, and then you're good.